This is problem number 10 from section 3.3. In this problem they say the graph of a function is given. Use the graph to predict the number of real zeros and the number of imaginary zeros. Find these two zeros using the quadratic formula. So we talked about this in the previous problem. We're going to pull this chart back up. But for part A, we need to figure out how many real solutions, how many complex solutions. Well, we know quadratics are going to have two solutions in most cases. If the quadratic or the parabola crosses the x-axis, it's going to have two real solutions, zero complex solutions, right? Because all quadratics have two solutions. So if they're both real, there's going to be no complex. If the quadratic or the parabola touches the x-axis once, there's technically two solutions, but they're the exact same solution. So it's really just one real solution, no imaginary solutions. And then finally, if it's not touching the x-axis at all, we're going to end up with two complex solutions. So this one, because it's not touching the x-axis at all, it has two complex solutions. So we'll write that in there, two complex solutions. Now for part B, they say, find these zeros using the quadratic formula. They give you the equation x squared plus 2. We're going to go ahead and use 0 for y. So we're going to say 0 equals x squared plus 2. Now, for this problem, typically I would not use a quadratic formula. In our four choices, which one would I use? I'd use the square roots method because we only have an x squared term. We could subtract the 2 over, take the root of it, and basically be done. But they want us to use the quadratic formula here, so let's go ahead and show that the quadratic formula still works. So this is technically, we're going to say technically, 0 equals x squared plus 0x plus 2. That just helps us for the quadratic formula. We'll write that in there. B is 0, so we have negative 0 plus and minus root 0 squared minus 4 times a, which is 1, times 2, which is c, and then all over 2 times a, which is 1. And that's x equals. Well, we end up with x equals plus and minus, because this cancels out, that's negative 8. Yeah, so we get root of negative 8 over 2. Now I can simplify that by saying I, plus and minus, I root 8 over 2. Now I need to take root 8 and I need to break it down because it does break down. Root 8 I know is root 4 times root 2. Well, root 4 we know is a perfect square, right? Which is just 2. So this ends up being just 2 root 2. And so I can write this now as x equals plus and minus, and I'm writing the I in there as well. So this would be 2I root 2 over 2. The 2's out front cancel, leaving you with x equals I, well, plus and minus. Let's go plus and minus here. Plus, we'll rewrite that. X equals plus and minus. 2's cancel, you're left with I root 2. So then you can just say that this is x equals I root 2 or negative I root 2. And those are the two complex solutions for this problem. Hope that makes sense how we went through it and evaluated it.